Let's take a look at the divergence test. We've already actually done this. We haven't necessarily formalized it, but we've already looked at this idea. If the series AN, this infinite series, converges, then the sequence AN must converge to 0. Now this is what's known as a one-way implication. So if this converges to something, a real number, then the sequence must converge to 0, period. By one-way implication, I'm saying if the sequence converges to 0, this may or may not converge. The series may or may not converge. Just because the sequence converges to 0, it doesn't mean that the series will converge. But if the series converges, then the sequence will in fact converge to 0. And I'll show you a couple examples of that. First of all, suppose we're considering this series the sum of n squared over n plus 1, and we're trying to figure out whether or not this thing converges. So what I'm going to do is I'm going to take a look at the sequence. So I'm going to take a look at the limit as n goes to infinity of n squared over n plus 1, which obviously this goes to infinity over infinity. So by L'Hopital's rule, this is going to be, whoops, forgot my limit. The limit as n goes to infinity of 2n over 1, which equals infinity, which is divergent. Therefore, the limit does not exist. Therefore, this series, n equals 1 to infinity of n squared over n plus 1, is divergent. I guess we could say by the divergent test. Let's take a look at this series. The sum n equals 1 to infinity of 1 over n. Again, I'm going to take a look at the limit as n goes to infinity of 1 over n. That equals 0. Well, I don't know if this converges or not by this test. I don't know. All I can say is therefore the sum n equals 1 to infinity of 1 over n might converge. Now, this is actually a harmonic series which diverges, and we'll show that it diverges here shortly when we introduce the integral test and we start looking at what's known as a p-series. Now, the sequence an, or if the sequence an does not converge to 0, then the series an diverges, which we said what we used up here. This did not converge to 0. This actually blew up on us and went to infinity. So we said that this series diverges. So if I take a look at this, I'm going to use the same approach. I'm just trying to figure out whether it converges or not. So I'll take a look at the limit as n goes to infinity of 3n squared plus 2n minus 1 over n squared plus 2. And through repeated use of L'Hopital's rule, what we end up with is the limit as n goes to infinity. See, the first time I take L'Hopital, I'll have 6n and over 2n, and the n's a cancel, so I have 6 over 2, which is just 3, which equals 3. So this limit is 3. Since this limit of the ANs here of the sequence did not go to 0, I can say that this series diverges. Therefore, the sum n equals 1 to infinity 3n squared plus 2n minus 1 over n squared plus 2 diverges.